So I will be explaining how to do question 3. First, the question asks to state the period, amplitude, phase shift, and the vertical shift, and then label the coordinates of the maximum and minimum point. So first, we can identify the A, which is the amplitude from this equation. This is the A, and the first step is to put this into factored form so that we can identify the phase shift and the B better. This will be 1 over 2. Because this is divided by 1 over 2, this will be plus 2 pi over 3. And from this equation, we know that this is the A, this is the B, this is the C, and this is the D. This is the vertical displacement, and this is the phase shift. We know that amplitude is the absolute value of maximum point minus minimum point divided by 2. So we know that it's this number, but there is no negative because the amplitude is the distance between the middle and the maximum point, or the distance between the middle and the minimum point. So there is no negative. So this will be 2. But when we graph it, we have to account for the vertical flip. And then we can figure out what the period is by using this equation. Period equals 2 pi divided by B, absolute value B. So this will be 2 pi divided by absolute value 1 over 2, and it will give us the value of 4 pi. Once we have found that, we can find the vertical shift. Since the general equation is y equals a cosine b x minus c plus d, we know that because this is a positive, because this sign is positive, it is actually moving to the left. So when we say phase shift, we know that it's left 2 pi over 3 units. And the vertical shift is the D. It will be -1, down 1. So once we have found all these points, we can start graphing. When we graph, we have to think about how long the period is. Because we know that the period is 4 pi and that the phase shift is left 2 pi over 3, we want to leave some space here and then use more space on the right. So I'm going to draw the x-axis here. One, 2, 3, 4, 5, 6, 7, 8. I will have this as 4 pi. This is pi, 2 pi, 3 pi, and 4 pi. And this right here will be negative pi over 2. Since the phase shift is negative 2 pi over 3, we will have to expand this a little bit. 2 pi over 3 should be approximately, this is negative pi, should be approximately here. Negative 2 pi over 3. So we have to figure out, this is the starting point, and we have to figure out where the ending point of the graph is. So by 2 pi over 3 plus 4 pi, that will give us the ending point, plus 12 pi, this will give us 10 pi over 3. 10 pi over 3 is approximately right here. Pi over 3. It's just a little over 3 pi. And then to find the, we have to divide the period into 4 quadrants, and each quadrant is pi. So to find the next quadrant, we can add pi to our original starting point. And that will give us pi over 3, which is approximately right here. Now, the dotted lines are just for reference. They're not part of the actual graph. And this is to find the next quadrant, be 4 pi over 3. Which is approximately right here. The next quadrant is 4 pi over 3 plus 3 pi over 3, which will give us 7 pi over 3. 7 pi over 3 is approximately right here. The next quadrant is 7 pi over 3 plus 3 pi over 3, which will give us 10 pi over 3, which is right here. So that is our ending point. Now we have the 4 quadrants. And then we have to find the D, which is the vertical displacement. It is at negative 1. We will label negative 1 here, negative 2, and negative 3, and 1, and 2. So we know that the amplitude is 2, which means the distance between the middle and the top and the bottom, or the maximum and the minimum. So if we start at negative 1, we move up 2, 1, 2. This is our maximum. This is going to be our maximum. We cannot exceed that. And move down to 1, 2, it'll be negative 3. Now these dotted lines are just for reference so that we can graph. So then when we graph it, we are not making mistakes. And this is our middle line, which means we always come back to this. So now we have to identify what the graph is going to look like. Since this negative 2 accounts for the vertical flip, we know that a normal cosine graph looks like this. However, a vertically flipped cosine graph looks like this. So we start at the bottom. First, we look at the C, which is negative 2 pi over 3, and then we go down to the minimum point, which is negative 3, right here. And then we have to come back to the middle, pi over 3 and negative 1. Then we go up to the maximum point, which is 4 pi over 3 at y equals 1. Then we come back to the middle again, 7 pi over 3 and negative 1. Then we come back to the minimum point, which is 10 pi over 3 at y equals negative 3. And this is what our graph is supposed to look like. Then we have to label the exact coordinates of a maximum and minimum point. So this will be the minimum point at negative 2 pi over 3 and negative 3. This is our maximum point at 4 pi over 3 and 1. And this right here is our minimum point again at 10 pi over 3 and negative 3. And there we have our answers.